Engineer CPWD is a graduate in civil engineering from Kerala University and MTech in structural engineering from IIT Kanpur. He also holds a postgraduate diploma in management after working in Tata Steel for 2 years. Joined CPWD in 1982 and since then handled many projects pertaining to hospitals, airports, institutional sports complexes, infrastructure, office complexes, housing, memorials and monuments.
I think we can reduce that, please. Thank you.
Can't we? कहाँ पर है? या ठीक है, मिल गया. Thank you, Chairman, and thank you, Emperor. The time is too short. Whatever time was given to me is already curtailed, so I have to really rush through if I have to do justice to the presentation. We are all familiar with precast construction, but rarely we do precast with the steel for the composite construction. In one of the major projects, we tried precast element and the steel to make the composite construction, the salient features of which will be presented here. The project was a combination of ROB. It is not exactly ROB, it's an ROB come flyover and RUB at the same level crossing, one above the other and one parallel to each other. And it was a very congested area, and the work has to be constructed without affecting the rail traffic as well as the road traffic. This was the existing position. The traffic was unruly, and a major part of the traffic was two-wheelers and a non-motorized vehicle. Segregating the thing was it was essential. So we have gone for a unique combination of ROB and ROB at the same level, with the ROB for the fast-moving vehicles and ROB for the slow-moving vehicles. The site photograph, the situation was complicated by the presence of a nala which was flowing in full brim, and the RUB has to be taken below this nala. The profile sketch, paucity of time, I am not explaining. Here you can explain that one. The yellow one is ROB, and the RUB is below the rail level, and RUB is much shorter than the ROB. The salient features about a kilometer of ROB, and RUB is much less, and the railway clearance was given 6.8 meters because it is going to be an electrified line. The section is an open section. It is on a central pillar. The deck is constructed, and this is a section at the rail where the closed section is provided. Box pushing is given for the RUB. And it is the top deck which we are talking about, which is going to be the precast construction. The sequence is something like this one. We cannot do bottom of construction, so we have constructed the ROB first, made it operational, then gone for the construction of RUB without affecting the traffic. So structural arrangement is somewhat like this one. It's all either 3 or 4 span. Diaphragm is given on the pier. Girders are connected to the diaphragm, and then precast slab is placed over the girders and make it composite. This section, I will skip it because of the time. We have got many advantages. It was much faster. We could complete the entire ROB within 10 months. And with the least disturbance from both the rail traffic as well as the road traffic, and the safety was much improved because of the least amount of construction activity at site. Here is a structural arrangement. Just the vertical one is the diaphragm, and the blue line is the girders. The diaphragm consists of a stub projecting out, and the steel girder is connected to a stub for easy connection. It will make it clear. The diaphragm is placed on the pier on 2 diaphragms. You can see the stubs projecting out of the diaphragm into which the girder will be connected. And this is the connections from both sides of the diaphragm. You can see one of the girder is yet to be connected. This is the arrangement of the deck slab. The yellow line shows the girder over which the deck slab will be arranged in this manner, and the precast slab is shown in diagonals. Each slab is shown in diagonals with appropriate space around it for connectivity. This gives a typical panel placed over the girder, and all round we are leaving the gap for subsequent connectivity to get the composite construction. The panel is thickness is 25, and the reinforcement is provided which take as a U turn and take into the top bars. The reinforcement is provided like this one. The shuttering is provided with the slots for the U-shaped bar to continue, and also provide with the facility to give a shear key within the precast slabs. And when the slab is constructed, something like this one, it is ready for lifting. You can see the U-shaped projecting reinforcement as well as the shear key. It is transported to site for construction. This is a section. You can see the shaded portion is the precast portion, and in between it is stitched together to make the composite action with the steel. And you can see the slab placed over the flange of the girder, and there is a neoprene pad is provided for proper seating as well as to prevent the slurry leakage when the cast in situ concrete is placed between the two joints. And here you see the entire width is provided the slab with the joint, the visibility is there. And the bottom photographs shows the joint. This is the transverse joint. The longitudinal joint is not visible because it is over the flange. And the cantilever is erected on a bracket which will be taken out after the joint is finalized. You can see the cantilever one which is being placed over the bracket. And the joint will be somewhat like this one, the left side. Once both the slabs is placed together, the reinforcement on both the slab will be intermesh, and the typical junction is known on the right side. And once this is placed, you have to make a composite action and also continuity with the slab panels. And that is where the detailing and design of the joint is to be made appropriately. The composite action was achieved through welding studs designed for shear, interfacial shear, for the subsequent load and for the fatigue effect. And the precast deck panel is integrated through a stitch concrete. The reinforcement bar is appropriately designed. And you can see the longitudinal junction here, the joint here, and the top one shows the flange over which the studs will be welded. The reinforcement is shown in the bottom figure. It is intermesh, and the plan shows between the two reinforcements coming from both sides, the studs will be welded. The dotted one, the black dots are the studs welded to the flange. And it is a transverse joint where the flange is not available. Here you have to provide a separate shuttering which will be sustained from the top to provide this joint. So joint construction sequence is somewhat like this one. First you place the slab, then the stud will be welded, and the longitudinal reinforcement will be inserted, and then non-stick concrete is provided in the joint, and after it is cured, you will get a composite section for the subsequent loads. And this is the stud welding in position. Welded studs are already given, shown in the left side, and the stud welding process is shown with the stud welding. It is more clear, the actual welding takes place. The right side is the welding machine. The studs are welded. So after the studs are welded, it looks something like this one. The joint is ready for the further reinforcement. And then longitudinal reinforcements are inserted between the loops of both the transverse reinforcement, and you can see both the junctions and the transverse joint here. And then the joint is concreted. The concreting is processed. It is clear here. It is when all the joints are completed and the cured, and some of the part is yet to be concreted. And the deck will be like this one after the stitch concrete ready at site. And of course, then the normal procedure of waterproofing, then wearing course, and interestingly, even the expansion joint is provided even after the final finish. After the wearing coat is provided, we have to cut the wearing course with a machine, exact line and level, and place the expansion joint in level with both sides to get a bump-free ride. And then concreting is done, and after curing, you will get a neat joint, and that is the last operation. The road is ready for operation. Briefly on the design, it is to be designed at 2 stages. Erection stage, where only the self-weight of the girder and the deck slab will be taken into account, and the steel is taken the entire load. And the service stage, you have to take the superimposed dead load as well as the live load, which will be taken by the composite section. Joint detailing, there is no guidelines in IRC. Some preliminary forms of guidelines in Steel Construction Institute for precast decks, which we have taken, but we are improved it upon. And the conventional concept of overlap as well as anchorage length is not applicable here. So to get the confidence, we are really done a test to effectiveness of the joint. A test was done before the construction was taken place at site. The test was done for the critical load condition. In the casting yard, exact replica was made as per the design requirement. You can see the girder as well as the precast slab and the stitch slab, which has been completed, and the load is applied. Of course, the static load is applied. And this actual loading took place. The critical condition was the cantilever portion, which is also precast. So there the load is placed to see the assessment. And acceptance criteria is given in IRC SP 51. And acceptance criteria is based on the percentage recovery. It is not on the deflection. It is a percentage recovery of deflection. And SP 51 gives different percentage recovery for different types of construction. For the RCC, for the steel, for the segmental, for the steel composite, all given. For the steel composite, it is given, it should be 75% recovery. And we have tested it. We have given a much better value, almost 90% of the recovery we have received. And it was with that confidence we have gone ahead. And court also specified there should not be any visible crack, there should not be any spalling, there should not be any compressor crushing. And that also we observed, it was found to be okay. With that confidence, then we started taking up the construction. Probably for the first time we could do a technique like this one, which was made a much faster construction than the traditional method of construction. Thank you. I hope I have taken all the time allotted to you.
Thank you. Excellent. Thank you, Mr. Abraham. We are now taking a short break where the questions, some 5 questions have been received, and the presenters will give replies to the 3 papers which have been presented so far. Mr. Vishwanathan first.
There is a question from Mr. Ram Chandani, retired secretary of PWD. FCTK 0.05 is a limit of tensile stress beyond which it can crack. Yes, the code has given the value allow up to which the section can be taken as uncracked section is FCTK 0.05 tensile stresses, which are given in table 6 of IRC 112. What exactly is the limit of deflection for such partially pre-stressed sections? Say it is a serviceably limit state and the comfort for riding is important. So if you go on section 12 last, due to live loads, with respect to span, we have given the allowable deflections. The neutral axis not closer than 100 millimeter means if a cable is there and your neutral axis up to 100 millimeter, you are expected to retain you have to have only compression, not tension, because if any cracking is allowed, this due to from the environmental conditions, the cables can get corroded. So this is the requirement of European codes that 100 millimeter around the cable should be kept in compression. Next is MOST and PCI, the major difference in analysis. There is no difference, but what MOST says is one can calculate the decompression stress either by way of adding the elastic shortening loss back, or you can really calculate, or for simplicity's sake, you can take the effective pre-stress itself as a decompression stress. Whereas the PCI mentions this, but all in their worked out examples, they have calculated the elastic shortening loss and added back to the pre-stressing stress, and that force is taken as a decompression stress. This is all the difference between these two. Otherwise, MOST also refers the PCI handbook's provisions, and PCI also clearly says the examples which are given in this book is based on MOST work which appeared in the structural journal of this year. So basically, there is no difference between MOST and the PCI approach. Thank you.
Thank you. We have one comment from Shri R.K. Jain, who is convener of H3 committee. He has asked us to suggest the modifications in regression equations in future. So we will be working for that. We will definitely bring out the regression equations. And then Mr. P.R. Chandak has also raised some points, which are the points actually we are also saying in our paper, that the records of temperature differential which has been taken in IRC 58 are taken from 1974 CRR records. So things have changed a lot now. Due to global warming, there is a change, so temperature differentials are also changed. So we have to work over that, and this is what we are saying, that we have to work in this area. But this is a normal procedure in our country. We take out the codes based on some other works in the world, and then we go on modifying them. So that we are proposing that the temperature differential work will be also done. And then regarding, he has said for less important roads having commercial vehicles more than 450 per day, Actually, these two things are contradictory. You can say less important roads, and when you are saying more than 450 vehicles per day, commercial vehicles, so these are not less important roads. These are important roads, and whether to take 150 or 100, again, this is the dilemma which is coming from this work which is presented in this paper, whether to go for 100 or 150. So further, Dr. Ran Singh Chung will tell about this. We are going to work over this area.
Yeah, for kind information, you'll be happy to learn that. Yeah, regarding coming to the temperature differential, we are already initiated in this area, and yes, it would be too early for me to announce to reveal out the result at the moment. We are in the progress. Yes, definitely there is a significant change, the significant reduction in the cement concrete slab thickness, because the temperature differential is affected by the humidity, relative humidity also, and the main source is the solar radiations. So, and I would like to pass on to my research scholar one more query is that he would be attempting.
This is the answer to Mr. N.C. Dora. He want to know why the concrete slab thickness reduced by increasing the K value, right? So by increasing the K value, that means CBR strength, by increasing the subgrade strength, the total stresses arising because of the axial loading reduces, whereas the warping stresses, that is the temperature stresses, increases. So when we combine both of them, the reduction in the stresses because of increase in the K value is more dominant as compared to the increase in the curling stresses. That's why with the increase in the K value, the slab thickness should reduce. Secondly, why the slab thickness is reduced by providing the hard shoulders. Because when we extend the shoulders or widen the shoulders, according to 58-2015, about more than 30% stresses passes on to the shoulders. That's why the slab thickness reduces. The second question is to specify the minimum thickness of PQC for 3.5 into 4.5 meter long core blocks. Actually, the thickness depends on so many factors, like how many commercial vehicles are flowing over it, what is the subbase, thickness of the subbase, condition of the shoulders. So on that we can specify the thickness. Without all these parameters, we cannot specify the minimum thickness.
Thank you. Mr. Abraham will answer one question. And after this, the authors or presenters who are on the dais will go down. And then for the next three papers, the presenters will come on to the dais. Mr. Abraham, please.
I got two questions from Sri N.C. Dora. I hope he's here. He has got two questions. Please elaborate non-shrink concrete and jointing between steel girder and the precast slabs. Non-shrink compounds are available in the market. These are basically compensating compounds. They compensate for the shrinkage so that the net shrinkage will be zero. It's available, and the exact dosage normally the manufacturer gives it. Then what are the length of precast concrete deck slab? The length was in the range of almost 6 meters, and width is around 2.5 or 2.6 meters. Thank you.
Right, please go ahead with presentation of mementos to the authors sitting on the dais.
Okay,
Quickly,
okay,
please.
Sir. Yes, sir.
One by one.
Now I request Ms. Madhvi, Ranjita, Shirisha, Saundarya and Meena to kindly present the memento to all the authors. Please. To Shri T. Vishwanathan ji.
Quickly, please. Thank you. Mr. Vishwanathan.
Shri Professor Praveen Aaron, Professor Ranjan, Professor Farida, and Shri K.P. Abraham ji, have you given? Now I request all the authors to kindly give
Can you
best.
please step down so that we save time?
Yeah. Now I request the authors of the other remaining 3 papers to please come on the dais. Professor Mahesh Tandon,
Thank you.
Shri Harsimran Singh ji, Miss Ishita Manjrekar, Raghuveer Salkar, Saurav Manjrekar and Abhishek Salkar.
The people who are presenting may come onto the desk. We don't need too many people. All the authors need not necessarily come onto the desk. Please.
क्या करूं? ये हाँ. Sir, you are making the presentation first. So